Okay, so now that I have my key points, I can actually graph this, and I'm going to think about an ideal way for me to actually graph this function. First of all, what I recognize is that the graph, whenever you're looking at an exponential function, usually the exponential function looks like one of these. So it's either an increasing function or a decreasing function. And the only way that might change is if there's been some sort of a reflection. And I noticed that there were no reflections in this case. So I'm going to expect the graph to still be increasing since the base of the original function was greater than 1. Okay, so let's try graphing this. So I have a horizontal asymptote at -4, which I need to make sure I have room for. And then I have all my values of y are greater than that. And my values of x are positive. So I'm going to set up my grid here. It's going to look something like this. So x and y. I'm going to extend the x values to about 3. And the y values, so -1, -2, -3, -4. 1, 2, 3, 4. And that should be enough space for my entire graph. So I looked at the points to figure out what my scale would look like. So the horizontal asymptote is at y equals -4, so I can draw that in. And remember, when you're drawing an asymptote, it's dashed lines because it's actually not a part of your graph. It's a restriction for your graph. So here's y equals -4. And then I can plot the points to sketch the rest of the graph. So I have 0 and -2.5 as my first point, 1 and -1 as my second point, and 2 and +2 as my third point. And what you'll notice is that this point here is very close to the asymptote. And so what that tells me is this part of the graph is increasing away from the asymptote, whereas this part here is decreasing towards the asymptote. So there's the exponential function that I'm looking at. Remember to extend your graph as far as your grid goes. And so this is the graph of y equals 3 base 2 of x minus 1 minus 4. Don't forget to label your graph as well. Okay, and then in part B, we're asked to state the domain, range, and the equation of the asymptote. So in terms of the domain, we're looking at how far the graph extends towards the left and how far it extends towards the right. And you'll notice that there are no limitations to how far the graph goes to the left and to the right. So I know the domain is x such that x is an element of all real numbers. In terms of the range, now because the graph moved down 4 units, the range has also changed. You'll notice that normally you don't have an x-intercept when you're looking at exponential functions, but because the entire graph moved down 4 units, you do have an x-intercept. Okay, that's irrelevant right now, but just so you know, transformations can make things that didn't appear before appear all of a sudden. Okay, so back to the range, you'll notice that all the values of the function are above the asymptote, which means all the values of the function are greater than -4. So in terms of the range, we have y such that y is greater than -4 and y is an element of all real numbers. Okay, so all the values of y are more than -4. Okay, the equation of the asymptote, we talked about that earlier. The asymptote has shifted down 4 units, so y equals -4. And then the last part, part C, looks at whether the function is increasing or decreasing. And so you can analyze that by looking at your graph. Remember to analyze the graph going from left to right. And you'll notice that as I move from left to right, the values of y are getting higher and higher and higher, which means I have an increasing function. And that's it for the first example.